Hello friends, this is the Westcoast Math Tutor. In the last video we did an example with exponential decay with a mathematical model for exponential decay. A equals A0 times e raised to the power of k times t. Today we are going to do one more example for the sake of practice. The half-life of strontium-90 is 28 years. In other words, after 28 years, a given amount of the substance will have decayed to half of the original amount. Find the exponential decay model for strontium-90. When we have problems like this, we plug in 28 for t and the half of A0 for A, like we did in the previous video. So we can write 1/2 times A0 equals A0 times e raised to the power of k times 28. And after cancelling out A0 from both sides, we get 1/2 equals e raised to the power of k times 28. Now we can take the natural logarithm on both sides. And with the inverse property, we get k times 28. Now we are going to divide by 28 on both sides. So we get k equals ln of 1/2 over 28. Now we are going to plug k into the equation. A equals A0 times e raised to the power of k times t. So we get A equals A0 times e raised to the power of ln of 1/2 over 28 times t, which is the exponential decay model for strontium-90. Suppose that a nuclear accident occurs and releases 60 grams of strontium-90 into the atmosphere. How long will it take for strontium-90 to decay to a level of 10 grams? Recall that A0 is the initial amount of the substance and A is the amount of the substance left after a certain amount of time. So we can write 10 equals 60 times e raised to the power of ln of 1/2 over 28 times t. The only thing we have to do now is to isolate t and we are done. How can we do that? I would encourage you to pause the video and try. Dividing both sides by 60 gives us 1/6 equals e raised to the power of ln of 1/2 over 28 times t. Now we are going to take the natural logarithm on both sides, and with the inverse property we get ln of 1/6 equals ln of 1/2 over 28 times t. Now we are going to divide ln of 1/6 by ln of 1/2 over 28 to isolate the t. And after typing this into the calculator, we get approximately 72 years. So after 72 years, 60 grams of strontium-90 decay to a level of 10 grams, and we're done with this problem. If you like my videos, like, share and subscribe. Thanks for watching and happy learning everyone.